First, the objects are placed onto an air-water meniscus, on which they are allowed to float independently of each other. And now, all the Legos are floating on the meniscus. Next, we introduce this fine piece of silverware to the system, a metal spoon that we like to call the agitator. We plunge the spoon into the water and agitate by gently shaking the spoon in the water so that light ripples form and the Legos begin moving. Due to the identical composition of each Lego, the Legos are attracted to each other. This phenomenon is analogous to the attraction of hydrophobic molecules to each other due to intermolecular forces, and is called cohesion. For example, cohesion of water molecules due to hydrogen bonding is one of the reasons why water is able to overcome gravitational pull and travel up the xylem of a plant. Note that this process is spontaneous, in that the attraction of Legos to each other does not require a constant input of energy by agitation. Here we have a system of 3 Legos. It is interesting to note that the Legos are not lined up perfectly. Small pushes on the system allow the Legos within a system to slide past each other easily. This occurs because the Legos share entire rectangular surfaces with each other. As a result of this frequent lateral movement, it can be concluded that smooth cubes are not good components to use if a stable self-assembled system is desired. A slight agitation by the spoon and the Legos come together to form a 4-membered structure. Now that the spontaneous self-assembly is complete, let's try to answer the most interesting question that has thus far remained unanswered. Why is this self-assembly spontaneous? In other words, what is the driving force behind the process? To answer this, let's look at the Gibbs free energy equation, a mathematical relationship between enthalpy and entropy by way of a quantity known as Gibbs energy. We know that the process is spontaneous, so delta G is negative. We also know that the final system is more ordered than the original mess of Legos, so delta S is negative. Finally, we know that T is a small number, as I agitated the water very little. Therefore, in order for the equality to hold true, delta H must be negative. Now, delta S is negative and delta H is negative. A negative change in S is not favorable, so entropy cannot be the driving force. However, a negative change in H is favorable, so enthalpy must be the driving force behind spontaneous self-assembly. So, just about now, you must be wondering who the owner of that perspicacious disembodied voice was. Well, it's me! Moving on, I concluded earlier that smooth, square cubes don't result in a stable, self-assembled system. Well then, what does? Let's experiment this time with rough, annular objects. Fruity Cheerios! First, the Cheerios are placed randomly on the same air-water meniscus on which the Legos were placed. The same metal spoon is used to lightly agitate the water and to get the Cheerios moving. Pairs and triplets of Cheerios begin to form due to the same cohesive forces. After some time passes, arcs of Cheerios and even chains of Cheerios begin to form due to these same cohesive forces. However, slight agitation with the spoon reveals that these long arrangements of Cheerios are short-lived. they quickly form more stable structures, such as the following. Even with more vigorous agitation, these clumps of Cheerios retain their ordered conformations and do not experience the same lateral jostling that the Legos did. Based on our analysis of the Cheerios, we can conclude that rough circular objects form more stable self-assembled systems than smooth cubical objects. Now, let's review the conclusions that we came to based on experimentation today. First, we concluded that enthalpy and not entropy is the driving force behind spontaneous self-assembly. This is because in order for the delta G term to be negative in the Gibbs free energy equation, the delta H had to be negative. The delta S's sign was not really relevant because the delta H was the determining factor. A negative delta H means a spontaneous process. Secondly, we concluded that smooth cubical objects make much less stable systems than circular rough objects, as demonstrated by the comparison between the Legos and the Cheerios. Now, on a lighter note, I learned today that the Moonlight Sonata makes great background music. That's all for now. Thanks for watching.